Okay, same problem again. Approximate the area between the graph of y equal x squared, the x-axis, and the vertical lines x equals 0 and x equal 2. In other words, approximate this area, but this time we're asked to use 4 rectangles. We've used 4 rectangles before, but we're asked to use midpoints to get the heights of the rectangles. So your book is going to call this M sub 4, M for midpoint. Okay, so the first step is always to partition your interval, and that's 0, 2. In other words, our vertical lines are x equals 0 and x equal 2, so our interval is 0, 2. I want to partition that into 4 equal parts, just like we've done in the previous 2 parts, A and B. So my increments are going to be 1/2, 3/2. That 1/2 doesn't exactly look halfway, does it? You'll have to use your imagination a little bit. So, and draw a vertical line to get the right hand side of the rectangle. But now, how do I get the heights of the rectangles? I'm supposed to use midpoints. So, what is halfway between 0 and 1/2? Halfway between 0 and 1/2 is 1/4. I'm going to put a little arrow here because that's my midpoint, and I'm going to use that to get the height of my first rectangle. What's halfway between 1/2 and 1? Halfway between 1/2 and 1. Halfway between 50 cents and $1. 3/4. That's my second midpoint. Halfway between 1 and 3/2. That's between 1 and 1 1/2. What's halfway between 1 and 1 1/2? Between $1 and $1.50. It's $1.25. It's 5/4, isn't it? Do you see a pattern? 1/4, 3/4, 5/4. It's odd numbers over 4, isn't it? And halfway between 3/2 and 2. It's halfway between 1 1/2 and 2. That'd be 1 3/4, right? But that would be 7/4. And that does fit our pattern of odd numbers over 4. So I'm going to let the height of the first rectangle be f of 1/4. So I draw a vertical line over x equal 1/4. And where that hits the graph is f of 1/4, and that's the height of my first rectangle. F of 3/4, draw a vertical line through x equal 3/4. Where that line hits the graph is f of 3/4. The height of the point where that line hits the graph is f of 3/4. Let that be the height of my second rectangle. Similarly with 5/4. And with 7/4. Okay, so these are my rectangles that compose my Riemann sum. The sums of areas of rectangles. The sum is composed of areas of rectangles. It's called a Riemann sum. And Riemann is the mathematician who is credited with doing this. Okay? So let's compute the area of these 4 rectangles, this Riemann sum that we're calling M4. But before we do any more, it's real obvious that this is a better estimate than the previous 2, right? The first one was way too big. The second estimate was way too small. And now I've got some of these rectangles, some of the area is outside, but then I've got some area that hasn't been covered, you know, like right in here or right in here, but it's kind of compensated for by area of the rectangles that goes outside the graph. So I still think my estimate may be a little small here, but it's way better than the other 2. Okay? Area of the first rectangle is f of 1/4. That's the height. 1/4 was my midpoint. So f of 1/4 is the height of my rectangle times 1/2. Again, my subintervals go from 0 to 1/2. That's a half. From 1/2 to 1. That width is a half. From 1 to 3/2. Again, that distance is a half. From 3/2 to 2, that distance is a half. Again, your width of your intervals is subintervals is always delta x is b minus a over n, which is 2 minus 0 over 4 in this case, or a half. Okay, that's my first rectangle's area. My second rectangle would be f of 3/4. That's my second midpoint. That's the height. The width is a half. My third subinterval, my third rectangle, the midpoint is 5/4. So the height is f of 5/4. The width is a half. And my last rectangle has a height of f of 7/4, a width of a half. And just like before, I factor out this 1/2, and so I get f of 1/4 plus f of 3/4 plus f of 5/4 plus f of 7/4. Okay? What's f of 1/4? Well, my f of x is x squared. Remember? F of x is x squared. So that's 1/4 squared plus 3/4 squared plus 5/4 squared plus 7/4 squared. So that's 1/2 times 1/16 plus 9/16 plus 25/16 plus 49/16. So how many 16ths do I have? 1 plus 9 is 10, plus 25 is 35, plus 49, I get 84. Just added 1 and 9 and 25 and 49. Okay, so a half of 84 is 42, right? But this fraction will still reduce. That's 21 over 8. Okay? So M4, the Riemann sum, using 4 rectangles and midpoints, is 21 over 8. And we've estimated the area, exact area under the curve, to be 21 over 8. So, from looking at A, B, and C together, our lower bound was, in the B part, our lower bound for the area was 3/2. So, I'm going to write from A and B and C, I know that my area is between 3/2 from the B part and from the A part, 15/4. If I look at this in eighths, that's 12/8 is less than the area, which is less than 38. Okay? And notice my 21/8 is in between here. And that's a much better estimate, just looking at this visually. We'll learn very shortly how to find the exact area. Notice we're just approximating the area. So in a minute, I'm going to ask you to look at page 369 in the book and an animation, and you'll see how you're getting much closer to the exact area by using more rectangles. Remember we said, or letting n go to infinity. N's the number of subdivisions or rectangles. Remember at the beginning of the semester we said that calculus is a method of calculation based on the concept of the limit? Well, the big problem of integral calculus is finding area under a curve. Okay? And the exact area is going to be the limit as n approaches infinity of sums of areas of rectangles. We're going to use infinitely many rectangles. Okay?